Hello. Hi. Welcome to this video. Today we'll be studying about how the internet works. So we've transitioned from IoT security, and now we'll be looking at this topic because before we move on to the IoT protocols and discuss about some of the IoT protocols like MQTT and maybe COAP, we need to understand some basic working of how the internet is operating. It'll be quite a practical, hands-on things which we'll be doing. So let's begin with our discussion. So, firstly, how do you find the internet? So, internet is a global network of interconnected computers that communicate with each other, and this allows us to send all sorts of emails, browse websites, and it connect globally. But there is a whole backbone behind it, like the physical internet layer and how all these devices are interconnected with each other. So the internet is connected via this physical infrastructure, including fiber optic cables. So there are a lot of fiber optic cables. I've drawn this below, and I'll show it to you. Certain routers and all these switches. So there are submarine cables connecting all the contents with the speed of light, and your router access point connects your particular home or campus network where you are to your ISP, and they ultimately connect to the larger network which make up this whole global infrastructure. So if we ping something from our browser IP, let's say I'll take this in this particular example, I'll take the example of one of my startup websites, let's say Quagga.com. So currently this is hosted on Cloudflare, and this is our basic website. So once we hit it, where the servers are hosted, how it is hosted, if it is serverless or not, so all these things we'll be like looking at. But point is that wherever the server is located and if information is being requested from somewhere else, all those packets have to transfer, and like that's how the internet is working. So but if we have to talk practically how we are connected to the internet, it is through our access point, or what we call as the router. So typically, if you go to any, let's say, academy.quagga.com, or let's say we have gone to quagga.com in our browser. So what happens? Our browser doesn't know the IP address of this site where it is stored, and it takes the help of a DNS resolver to find out. And this domain name system, DNS stands for domain name system, is like the phone book of the internet, which contains like where this website is stored at which server, and there are huge data centers, and sometimes in a single IP address multiple sites are stored, so it resolves based on the host name. So that's how all this mapping is done. So whenever we have to find out the address where the website is stored, we generally this we have this client available with us, so which runs on our own device and sends the DNS request. So this is sort of like an inherent caching which happens at the uh, our OS level itself. And then there is a recursive resolver which usually is maintained by our internet service provider, or the Google's famous 8.8.8, which finds the IP for you where it has been stored. And then we have an authoritative name server. So there are only 12 authoritative name servers which record this information. Let me show that to you. So authoritative name server is actually like what is finally giving you the IP address. So this is one of the diagrams by Cloud DNS. So if you're querying uh, so you make a DNS request, and then this recursive DNS server which you were talking about, then first if it sees that if it is already has this cached inside it or not. If it does not have it cached, it will ask the root server that, hey, where is this website? So root server will respond that I'm not sure about where your website is, but I know where this .net is. So in the root servers, there are only 12 root servers which are maintained. So there is a proper list of these 12. So there are, sorry, 13 name servers are there. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, and each maintained by different companies. So these are the main operators like who maintain that root level hierarchy, that whatever the top level domains have to be registered, they know exactly where those are. So let's take a quick example actually from this, that what we just saw right now about the root level and that authoritative thing. So I have this here with me. All right, so we'll run this command. So it's NSLOOKUP is basically help you look up where the records are, and we'll try to find the .com, and we'll try to query this root server, a dot root server. So out of all these root servers which I showed you, we'll use this A2 query for the .com where this top level domain is hiding, and it will give us the information that okay, it will tell us where this .com domain is, and there we'll uh, query that .com servers, and like this there are like .org, .xyz, like in .co.in, .gov. All these are different top level domain servers, but the information of where that server is comes from the root server. So let's open the VS Code, and so again I'll this the command which I'll be using is, yeah, so instead of querying quagga.com directly, first I'll query where that .com file is. The command for that we have it here. So we'll use this command. So it's an NSLOOKUP command where we'll try to find where the com domain is, and I'll just copy this up. So now you'll see the expected output show us all the top level domains where the .coms uh, addresses where the com is hosted. So LJJH, all these are like a everything. So all these are the different servers where our. So now what we'll do is we'll just copy any of these particular things, whichever you want, A, B, C, D, anything, and we'll run that to exactly figure out where our quagga.com is. So here for now I'm using this a GTLD server, and this will help us figure out that where my company's this website's actual IP addresses. So if you look at this hierarchy, we first of all queried the root server and we got this. Now we're querying this TLD server and we're getting what is the authoritative DNS server for this. So it says that the authoritative name servers, DNS servers, it has given me the information that okay, this is the IP address where you can catch when you can get the actual website from, and I can query this website, and you notice this 172.64 32.168, and the name servers, all these name servers are actually belonging to the these name servers are belonging to cloudflare.com, and this is where my website is hosted. If I show Cloudflare, so this website quagga.com is hosted on this thing, and getting this practical perspective and trying to understand what these DNS records are, how they just would help us understand like in general about the protocols, because all this is based on like the standard HTTP S based protocols. So you see that this is our um, Quagga's um, dashboard, and if I try to look at the DNS settings, the DNS records of this. So all these DNS records will actually be pointing are pointing to that, and you see those name servers which we just saw, which we now just saw. So all this information your OS is also caching, your recursive things is also caching, and finally we'll have this authoritative DNS server. So that I'll discuss next. We'll actually, towards the end of the video, see on how to deploy a dummy website of fully functional backend and look at its records. Yes, let's continue with our discussion. So, there is actually very interesting video before we proceed forward. So now that you've understood the basic concepts, that will tell you exactly how from the root level the packets are transferred, and in our, like, DNS resolver, how it does that. We just now had a discussion about DNS resolver. So I mean, watching that video and then we discuss this will make the concepts more clear. So let's just quickly look at that. So this is a video which is almost 12 years old, but still clarifies the concept.
Have you ever wondered what happens when someone in England visits the World Science Festival's webpage? First, their computer needs to ask the World Science Festival server for a copy of that webpage. The computer sticks this request into a virtual envelope called a packet, wrapped with specific information about that request, including the World Science Festival's IP address. The computer sends this packet out of the house and below the street address.
So this IP address information which we have.
About that request, including the World Science Festival's IP address.
So we just now had a discussion how to figure this out. They will tell you later on the video also, but I just wanted to explain this part to you, that how we figure out the address of the website from where we want to query. So because it has been covered in the later part of the video, but anyways, let's just watch that.
The computer sends this packet out of the house and below the street via large underground copper wires. It passes through small regional networks before ending up here at Telehouse North in London. Telehouse North is England's main internet hub. The IP address on this packet tells the hub that the World Science Festival server is actually in Los Angeles. So Telehouse North sends the packet out as light across the Atlantic, over fiber optic cables buried deep beneath the ocean. The packet ends up here, 60 Hudson Street, New York City, the largest internet hub on the East Coast. This hub sends the packet through a series of regional networks connecting New York to Los Angeles, where the World Science Festival server resides. The server reads the request and gets ready to send the web page to England. But web pages made up of images and text are too large to send as a single packet of data. So how do we get it back to England? Imagine a group of 5,000 tourists visiting New York City in a single gigantic tour bus. They are way up in Harlem, but they want to visit the Statue of Liberty before it closes. But it's rush hour, on a Friday. There's no way that giant bus is going to fit through those crazy congested streets. So they decide to get off the bus and spread out. Some take the subway, some take cabs, a few rent bikes, and some even take kayaks down the Hudson River. How they get there doesn't matter, as long as they get there on time. Likewise, for the internet to work efficiently, this web page is pulverized into thousands of tiny packets of data, each one wrapped with all of the information it needs to rebuild itself in England. The packets are sent to LA's One Wilshire hub, which checks the traffic report before sending them off. Through miles and miles of land they travel, checking in through different hubs. Like our New York City tourists, those packets don't care how they get there, as long as they get there as fast as possible. Most of them will go through 60 Hudson in New York, where they are redirected back to England as light, riding a fiber of glass as thick as a silver dollar. Then back on copper wire, through regional British networks, until all the packets reach their destination and this epic journey, it all happens in about a second, along with trillions upon trillions of similar journeys that happen each and every day on this remarkable, easy to take for granted network of networks we call the Internet.
Yeah, so in this particular video, we were like that information about how this thing is resolved, that is not covered, but it's more like a high level structure. The whole motivation which we want to have here is basically that how these packets are broken, because in IoT these packets itself become very important because there is a computation involved in actually making these packets, and not just computation in figuring out the headers etc, but also storing these information. That also becomes a big hurdle. So we want these protocols, so when they were designed that infrastructure keeping in mind the normal computers, but IoT devices are very small, battery powered, and have very less computation inside it. So how do we modify these? So these sorts of things will lead us to more advanced implementations and different protocols like MQTT protocol, which are much more uh, relevant from the IoT landscape perspective. So, but let's just quickly discuss this diagram also once. So here, like just how we discussed, this is a computer, and if in our local stub we have this information about where that internet is, like if the browser, the website is cached, it will just, as soon as we enter it onto the browser, it will just give that information back to us. But assuming it is not there, then it queries some name server, DNS name server, that okay, please can you help me find where this website Huawei.com which I'm looking for, where is it available. So as we saw that in this example also, if we just do ns lookup of 888, where this ns lookup, so the 888 is located at the 8888, so that's the beauty of it, and it's the DNS of Google. And similarly we have the 1.1, the famous 1.1.1, which is owned by Cloudflare. So everyone has their specific things, and some of these name servers maintain the information that okay, they keep on indexing time and keep on caching the information. So once we query that, so if it is, if it knows about it, then it will return it, that hey, here you go, this is your address. But if it does not know, then it will actually go ahead and look for like okay, I'm not sure where this is, but let me contact the root. So these roots are like the mafia, where they store the all the top level names like .com, .net, .co, coffee, Japan, .ph, etc. And they tell, okay, I'm not sure where the address which you're looking for, but I can tell you where the .com is. So where the host names of .com. So this is what we actually looked in the starting of the video. They will go to this. This is the example which we took. So it will this this resolver. This root replies ask the top.com TLD server. So these TLD servers will reply, okay, um, I'll tell you where this server is actually located, and you can just use that. So this will reply with an authoritative name server. So authoritative name server is like how we saw the name servers of the Cloudflare account, and it will, we'll just ask them what is the IP address of this any academy.quagga.com or something, and then this authoritative name server replies with the actual IP address. So this is what we'll see right now. We saw before also this part. If we query the quagga.com with this, then it will actually give us I think we just now did let me see, yeah. So where this IP address is stored, it will tell you okay, 173. So many records are there, and these are the IP address, like where the name servers are, in which the particular IP address will belong to you. So here we can do an NS lookup of quagga.com with this, and it's telling okay, 172.67.209. So this is the exact IP address where you have to look up for this particular address. So many of these DNS records, whatever they are like in the name servers I was showing you. So there are A records which actually map the domain to the IP address. So if we look at this particular example, then let me show you one another one which is much more relevant to us. There is another domain which I have here. So if I show you the DNS of this DNS record, so this DNS record is actually pointing, this domain is actually pointing to one of my servers. So this particular server is actually owned by me, and I'll quickly show it to you. If I connect to host and configure SSH host, so this server is actually pointing to this 4 247 161 245 161 245, and here on a particular port I have opened the port, anytime you interact on the HTTP, it will directly reroute to port 80, and if you're doing it with HTTPS, it will reroute to 443. So if I type let's say this an-turing.com, so this is just where I have hosted a portal which I use for my small day-to-day work, whatever it is. And it has an all the APIs also along with this are all these APIs are also hosted on it. Everything is hosted here itself. So if I have to figure out, if I'm entering something here, where is it loading, which API call is it making? So what I can do is I can just open Control Shift I, and I can just go into the network tabs. So let me quickly show you an example. Okay, so this was actually this part of it was hard coded, but yeah, let's say I'm putting any problem 000, and you can see that every time it is doing a status check, but since my server, it's just the front end which is getting loaded, my server it's not responding it back. So all these headers which you see, it's trying to request the URL on the port 8080. So what generally happens, this API which I'm trying to query is should be running on the localhost 8080, and then it will start to get that. As a simple example, like if I open this up, connect to host, and I actually open this server, and let me open the terminal ports. So right now no ports are forwarded, but forward, I forgot in which port I hosted it, but so now you see that we've started to get status as okay, because now I forwarded my port of this server to the local host, and all the API calls which I'm doing right now are happening on this local host. So now the status has started to get all right. So you can see that how a typical thing is there. And if you open any website, like I'll open my uh, startup's website, and if I click on login, I'll choose to log in as a professor. So I'll just before pressing that, I'll filter out all these things, and I'm using only the fetch and XHR requests. So I if I log in as, let's say, this account, then you can see that this login request was made to this API endpoint, and I can get lists like similarly whatever endpoints I'm accessing, trying to access here, all those endpoints. Um, so anytime like I can filter out, okay, what API calls happened. So this is how we actually do debugging, penetration testing all the time. We try to see uh, what all APIs are there, what all APIs are having what security, and certain request headers are there. Once we log in, this bearer token is there, which will is like a unique thing. If I attach this bearer token, then I can make the API calls. Without this bearer token, I cannot. So this goes as a request header. And once we see the postman also, I'll show you the postman later. So there also we can make these requests. So once you get the bearer token, you can access each and every part of this thing. So let me just for now keep it in my clipboard. And so what generally happens, what's the whole point in showing all of this is that these are really, really intensive operations. A lot of compute is happening behind the scenes. If there are so many headers to handle and then request response, so request response cycle is not just meant for the IoT space. So that's why we have to go to something more advanced. And we therefore look at more advanced thing, which is the MQTT protocol. So let's just quickly wind this topic up, that how a simple thing like this works. So I just now showed you little details about the AAA records, where like how it is the domain which it is actually pointing to, the name server of that domain. CNAME is the alias to the other domain, like www.quaggy.com should point to quaggy.com. And then for the mail related mail exchanges, we have mail.quaggy.com. And then reverse lookup, if we have to do that, what does this IP address, what whom does it actually belong to. And there are a lot of injection techniques, like a lot of hacking techniques which can, like we can take advantage of in this. So traditional DNS uses the port 53 and sends requests unencrypted, and anyone in the network path can see what domains you query and spoof all these responses. So all this network which is going here, like as I was telling you about, like um, from the information here, the authoritative name server, etc., all this information finally, like it's sending us the thing. So all this happens unencrypted, and anyone can, like just all these things happen through the UDP port over port 53, and all this is unencrypted. Anyone can see what domains you're querying, even though they will not see the information which you're sending, but what sites you're accessing daily, that also is like a big risk. um, And a very simple hack that happens is that you're querying some DNS server, and instead of you getting the information from the DNS server, someone is spoofing that. Okay, instead of telling you the correct server, they tell you a different server, and then you start pinging, sending your request to that server. So all these things happens, and there are a lot of there are, like a lot of solutions to avoid this. Three I've mentioned: DNS over HTTPS, which secures it, then DNS over TLS, and DNSSEC, so cryptography signs DNS records to prevent tampering. So one is using the HTTPS traffic, other one is using TLS port 853, and that's how they avoid this uninterrupted traffic channel analysis. And even if you open Wireshark right now, so with Wireshark also we can see that, okay, which person is accessing which website, at least which IP address is accessing which website. So this is a typical TCP TLS HTTP handshake. So it opens up a TCP connection via TCP handshake. This is a three-way handshake. One is the sync, then acknowledge, and then acknowledge. So it establishes a TLS handshake, then it uh, sends an HTTP request, basically like sort of like a GET request, as you saw here in the website which I was showing you, that it was a GET request. If you're posting something, then it would be a push request. Like if I, let's say, add a student right now here, and some random email address I'll type right for now. So you observe that what happens here. So it made this request, and this was a post request because I actually submitted something, and so this was the payload. Like, what was the payload inside that, and the preview of the code which I received, and what was the response looking like. So a unique generated ID, user ID I was assigned, and everything. Whatever is the response, I'm getting that. So this is how it typically works. Uh, the client hello, the server. Like before that, we established this HTTPS, so this happens automatically. So, and finally, we get responded with some HTML, CSS, JavaScript. So, life cycle of an HTTP request is basically client sends an HTTP request to a server. The request method includes get, post, put, delete, and some headers and cookies. The server processes and replies back with the response code and some content. And browser assembles and displays this content. And multiple requests may follow, like for getting some scripts or running some, like for getting some images, running some scripts, etc. And we've already looked at all these demos. One thing which I wanted to show you is the Wireshark thing, with the DNS over HTTPS enabled and disabled, but that'll be for some other day. And yes, this is like a quick recap. You can go over through it. Next, what we're going to study is the MQTT publish subscribe protocol for IoT systems. Thank you.